Captions in English, please. So this is the second video of chapter 7. And we are trying to predict the product of a precipitation reaction. And so this second video will be going over the solubility rules. So if you remember, we had seen a yellow solution, yellow color, clear solution being mixed with a colorless clear solution, and we saw a yellow precipitate forming. And so what happens is that when you look at what's going on in the solutions is that instead of K2CrO4 units, we have K plus ions and then the chromate ions, CrO4 negative 2. So that's what happens when we have an aqueous solutions. The ions dissociate completely and they are free from each other and surrounded by molecules of water. And so in the barium nitrate solution, we have the ions Ba2 plus and the nitrate. And so now these ions are free floating in the water and they can mingle and interchange partners. For example, the positive ion potassium can mingle with the nitrate. And then the barium 2 plus can mingle with the chromate. And so this will lead to new possible product. And so if we put together the potassium and nitrate, we get the KNO3 formula. So that's going to be one of the product. And then if we put together the barium and the chromate, we get the formula BaCrO4. So that's the two possible products from this mixture of ions. And so based on a set of solubility rules, BaCrO4 is a solid in solution and KNO3 dissolves into water to make an aqueous solution. And so we would finish writing the chemical equation by writing the formula BaCrO4 and then put in parentheses that it's actually a solid, so S for solid. And then the KNO3 solution would be an aqueous solution, so AQ to refer to the fact that it's a soluble in solution. So that's how we would find the product. So for this, we need solubility rules. And so for ionic compound, empirical rules of solubility have been deduced from observations of many compounds. So empirical rules means that they are only coming up from observations. There is nothing that can allow you to predict that. You have to use those solubility rules. And so they are summarized in table 7.1 from your textbook, and that's the table you see in this slide. However, the chart below is from your book, and there are some ions that are left out of it. And so the slides that follow are more complete, and we will ask you to actually use the other table I give you rather than the table from the textbook because it's not complete. So here is a flow chart showing how we can deduce from some of ions if they are soluble, ionic compounds. So this is all about compounds that are mostly soluble. So compounds that contain lithium, sodium, potassium, ammonium, nitrate, or acetate are always soluble. There is no exceptions. So notice here there are some ions that are surrounded by a red box, and that's the ions that are not included in your table in your textbook. So that's why you need to use this chart or a table I will show you later on. So compounds that are mostly soluble are also compounds containing chloride, bromide, or iodide. However, here there are some exceptions. If the compound also contains silver, mercury, or lead, if they contain those, then it is insoluble. If you do not have one of those cations, then it stays soluble. Other mostly soluble compounds are those containing the sulfate, SO4 negative 2. Again, there are some exceptions. If the sulfate contains strontium, barium, lead, or calcium, then it's going to be an insoluble combination with the sulfate. Otherwise, it's soluble. So let's go through some more examples here. The solubility rules indicate that compounds containing lithium, sodium, or potassium ions are soluble. For example, lithium Br or LiBr, lithium bromide, sodium hydroxide, NaOH, or K2CO3, potassium carbonate dissolve in water to form strong electrolyte solutions. The solubility rules state that compounds containing nitrate or acetate ions are soluble as well. And again, there is no exceptions with those. So compounds containing silver nitrate, calcium nitrate, or calcium acetate dissolve in water to form strong electrolyte solutions. So let's look now at the flowchart for the compounds that are mostly insoluble. So all of these lead to insoluble compounds most of the time. So these are the hydroxide ion, the sulfide ion, the carbonate, and the phosphate. If we start from the right side here with the phosphate and the carbonate, they are mostly insoluble. However, if they contain those compounds like lithium, sodium, potassium, or ammonium, then they will be soluble, because remember how these are having no exception at the solubility. So then even with carbonate and phosphate, they will be soluble. Compounds containing the sulfide ion are mostly insoluble. However, if the compound contains lithium, sodium, potassium, ammonium, calcium, strontium, or barium, they will be soluble. So a lot of exceptions there. And the hydroxide has the same exceptions with the alkali metal and the ammonium. If those are included in the compound, it will be a soluble compound. If they contain calcium, strontium, or barium, and the hydroxide ion, they are slightly soluble. Otherwise, they are insoluble. So even if it's slightly soluble, you will consider that as insoluble. So for example, the solubility rules state that with some exceptions, compounds containing carbonate and phosphates are insoluble. For example, calcium carbonate, strontium carbonate, aluminum phosphate are classified as insoluble in water. So because they are insoluble, some ions on the surface of the crystals may, still get dissolved. And so that's why they are also weak electrolyte. Some ions may, dissolve, and then you have some weak electrolyte there. Note that the solubility rules contains many exceptions, right? You've seen many exceptions, so you have to read them carefully to not miss an exception. For example, compounds containing carbonate and phosphate are soluble when paired with lithium, potassium, sodium, and ammonium, because we've seen from the previous flowchart how these always lead to soluble compounds. So even with anions that are mostly insoluble, they will still make soluble compound. For example, lithium carbonate, sodium carbonate, potassium phosphate, or ammonium phosphate are soluble. So you have to learn to read this table and make sure you don't miss the exceptions. And so this is the table I will provide in Canvas, and that's the one you will want to use for your exams or quizzes, and it will be available for exams and quizzes. And that's the one you should also use for your homework, because sapling learning will probably use some of the ions that are not included in the table 7.1 from your textbook. I think sapling also provides, solubility rules also when you need them. So learn how to read this table. This is important. So the first part, the top part of the table, is for compounds that are mostly soluble, and then there are exceptions. And the bottom part is for compounds that are mostly insoluble, and then there are exceptions.